Next definition is heat of neutralization. Here the neutralization means what? When acid reacts with base, then salt and water are formed. That is called neutralization. We know that very well. Heat of neutralization means when 1 gram equivalent weight of an acid reacts with 1 gram equivalent weight of base to form 1 mole of water. In such process, some amount of heat liberate. That heat is called heat of neutralization. That means in this process also every time heat liberates, like heat of combustion. That is why this is also exothermic reaction. Next, one more point. If 1 mole of water is formed in such process 13.7 kilocalories heat liberates, or 57.3 kilojoules heat liberates. If 1 mole of water is produced in a given reaction, then this much amount of heat or this much amount of heat will liberate. This is the value in kilocalories, this is the value in kilojoules. See, if you see this example, then you get idea. This is acid, this is base, then we get salt and water. Here 1 mole water, that 1 mole water is formed, so energy is this much. In this case 2 moles water, then energy is minus 27.4 kilocalories. That is about heat of neutralization. Next one, heat of atomization. Atomization means if a molecule converts into atoms, in that process some energy is needed. That energy is called atomization. What is the definition? The amount of heat is absorbed, because we are going to split the molecule into atoms. It needs some energy. That means energy is absorbed. The amount of energy is absorbed when 1 mole substance is completely converted into atoms. Is called heat of atomization. If you see this example, then you get some idea. H2, 2 hydrogen atoms are present. This is molecule, 1 mole molecule. When we apply energy, then this hydrogen molecule converted into atoms. That is 2 hydrogen atoms. For that process, some energy is needed. That energy is called what? Heat of atomization. Next one, heat of solution. How solution is formed? When solute reacts with solvent, that is solution. In that process, sometimes energy liberates, sometimes energy absorbs. That is why the change in enthalpy means liberating or absorbing energy. The change in enthalpy when 1 mole of solute is completely dissolved in excess of solvent. 1 mole of sodium chloride is completely dissolved in excess of water, then that is called heat of solution. Sometimes in case of NaCl, energy absorbed. In case of some salts, energy releases. Then that is called what? Heat of solution. Next, heat of dilution. Dilution means what? Addition of water. Then what happens? More concentrated solution becomes less concentrated solution. In such process also, sometimes heat liberates, sometimes heat absorbs. That's why the change in enthalpy. When more concentrated solution becomes less concentrated solution upon dilution means addition of water, is called heat of dilution. Next one, heat of hydration. Hydration means what? Addition of required amount of water. Addition of required amount of water, that is called hydration. Then also sometimes heat liberates, in some cases heat absorbs. That is why that is the change in enthalpy when required number of water molecules is added. Every time we used to mention change in enthalpy. Why? In some substances heat liberates, in some substances heat absorbs. The change in enthalpy when required number of water molecules is added to 1 mole substance is called heat of hydration. See, this is 1 mole substance. Here we are going to add 5 moles of water, then we get this compound. This is colorless compound. Before adding water, this is colorless. After forming product, that turns blue color. That is about heat of hydration. Next, standard enthalpy of phase transition. Standard enthalpy of what? Phase transition. Phase transition means one physical state of substance changes from one state to another state. Among them, first definition is standard enthalpy of fusion. In that case, what is the definition? The amount of heat is absorbed. Fusion means what? When solid is converted into liquid, that is called fusion. That is also called melting. In case of fusion or melting, energy is needed. That is why energy is absorbed. That is why here they mention heat is absorbed when 1 mole of solid is converted into liquid under standard conditions, because this is standard enthalpy fusion. That means this process should be done under standard conditions. See, this is 1 mole of solid. When we apply heat, then 1 mole liquid is formed. This is about standard enthalpy of fusion. Next one, standard enthalpy of vaporization. Standard enthalpy of vaporization. Vaporization means what? When liquid is converted into gaseous state, that is called vaporization. So, for that also energy is absorbed. That is why the amount of heat is absorbed. Here, see, energy is absorbed. That point is mentioned clearly. The amount of heat is absorbed when 1 mole of liquid is converted into vapor is called standard enthalpy of vaporization. This is the suitable reaction for that given statement. Next, standard enthalpy of sublimation. Sublimation means what? When solid is directly converted into gaseous state without converting into liquid state. That is called what? Sublimation. Standard enthalpy of sublimation means when 1 mole of solid substance is directly converted into gaseous state without converting liquid state. For that process, some energy is needed, some energy is absorbed. That energy is called standard enthalpy of sublimation. It should be done under standard conditions. That's all. That is all about standard enthalpy of phase transitions. Next one is Hess law. This is very, very important point. This is also called Hess law of heat summation. First I will explain the example, then I will tell about statement. See, if you see this one, here D is the product, A is the reactant. D, in the first step, D can be made directly from A, that is direct step. In that step, for that step, some energy is needed. Let us assume that energy is Q. D also can be made from A by different steps. These are different steps. This is the first step, this is second step, this is third step. These are called indirect steps. What is the statement here? What it says? If D obtained in one step, nothing but direct step, it needs some energy. That energy, that heat will be equal to sum of heats of 3 steps, nothing but sum of heats of different steps, nothing but sum of heats of indirect steps. Mathematically, it shows Q equal to Q1 plus Q2 plus Q3. If you see this example, then you get clear idea. See, in this step, carbon dioxide made from carbon and oxygen directly, it needs this much energy. That means this energy liberated. This carbon dioxide can be made from carbon and oxygen in different steps. First, when carbon reacts with half amount of oxygen, half mole of oxygen, then we get CO. When it needs some energy, that is this. When this CO reacts with another half mole of oxygen, then we get CO2. Here we got CO2 in one step. Here we got CO2 in 2 steps. This is one step, this is second step. For each step, some energy needed. If you sum these two, minus 110.5 plus minus 283.0, then that will be equal to this one. That is called Hess law. So what is the statement of Hess law? The total amount of heat is the same whether the reaction takes place in single step, that means single step, or several steps. These are several steps. Several step means more than one step, that is called several step. This is the best example for that. You have to remember that example. In the next video I will discuss numericals regarding heat of formation, combustion, neutralization, Hess law. Those are very important in competitive level. Thank you.